Hello everyone, today we're presenting our project, the AI Integrated AED System. Our goal is to revolutionize emergency cardiac care with the principle of smarter shocks, better outcomes, more lives saved. This project is brought to you by Team DeepSick, consisting of Lee Youngjian, Reeve Chongjilok, Wee Jungqing, Daniel Anik Haikal bin Nur Ikwan, and Chan Kar Kai. Let's begin with the core problem we're addressing. Current automated external defibrillators, or AEDs, use a standardized fixed energy shock, typically 200 joules for adults and less than 100 for children. This one-size-fits-all approach completely ignores critical patient differences like age, weight, and the duration of the cardiac arrest. This can lead to shocks that are either too weak to be effective or too strong, causing unnecessary cardiac tissue injury. Considering that sudden cardiac arrest affects millions of people worldwide, this is a significant gap in emergency care. To address this, we've set out 4 clear project objectives. Our primary aim is to develop a smarter, patient-centric AED system that personalizes the shock energy level based on individual patient profiles. This will be achieved through AI-powered rhythm classification, which analyzes heart rhythms in real time to guide defibrillation decisions. The ultimate goal is to improve resuscitation success rates while minimizing physical risks. Crucially, we aim for seamless hardware integration, allowing our AI software to be added to existing AEDs without the need for expensive replacements. Looking at the background and market need, we see that while traditional public access AEDs are widely deployed, their core technology has a major limitation: the fixed energy, one-size-fits-all delivery model. This creates a critical gap in the market. Despite millions of devices being installed globally, none can adapt in real time to the unique characteristics of a patient. This gap leaves patients vulnerable to either ineffective treatment or unnecessary tissue damage, a problem our solution is designed to solve. This brings us to our innovation, an AI-driven adaptive AED system. Our system personalizes shock energy delivery in real time. Instead of a fixed value, our system adapts to each patient. It achieves this through 4 key components: advanced patient profiling, real-time ECG classification to understand the heart's rhythm, dynamic joule calculation to determine the precise energy needed, and an adaptive AI engine that ties it all together. The development of this system involved extensive programming work. As you can see from this code snippet, we've built a software foundation for our adaptive AED system. This includes the logic for the user interface, data processing, and the algorithms that drive the real-time calculations. This technical backbone is what enables the system to analyze patient data and determine the optimal personalized shock. So how does it all work in a real-world scenario? It's a simple 4-step process. First, the responder attaches the electrode pads to the patient to begin cardiac monitoring. Second, our integrated app captures essential biometric data like age, gender, and weight. Third, our AI engine continuously analyzes the ECG signal in real time to accurately classify the cardiac rhythm. Finally, the system calculates and delivers a personalized shock, for instance, 182 joules with 98.6% confidence to provide optimized defibrillation. Our methodology followed a structured 4-phase development process. We began with in-depth research into existing energy guidelines and personalized shock formulas. This was followed by the core programming phase to build the software. We then moved to physical prototyping to test the system in a simulated environment. Finally, we are in a continuous cycle of improvement, iteratively refining the application and its user interface based on testing and feedback. What makes our solution innovative and novel? It's the AI-driven software layer that transforms static hardware into a dynamic adaptive system. Our key competitive advantage is the ability to deliver personalized energy levels, which reduces ineffective shocks and minimizes tissue damage. This system offers seamless compatibility, integrating with existing AED hardware without costly replacements. At its core is a patient-centric design philosophy. The AED adapts to the patient, enabling a smarter, safer emergency response. The potential impact of our system is significant and multifaceted. On a social level, it can improve survival rates from out-of-hospital cardiac arrests by delivering precisely calibrated shocks. Medically, it represents an advancement in personalized emergency medicine by reducing the tissue damage caused by one-size-fits-all energy delivery. It also promotes inclusivity, creating a safer AED designed for diverse populations. Ultimately, this transforms static hardware into an intelligent, adaptive system, setting a new global standard for cardiac emergency care. Regarding feasibility and sustainability, our system is built on a solid foundation. It's designed to meet IEC 60601 medical device standards and align with AHA resuscitation guidelines for safe clinical deployment. The software-driven model is highly scalable and can be adapted for use in hospitals, ambulances, schools, and homes. It is also cost-effective, as it retrofits existing AED hardware, avoiding the high cost of full unit replacement. Finally, its modular architecture ensures it can be easily updated to maintain compliance and add new features. Looking ahead to future development, our plan includes several key areas. We will establish revenue streams through a software-as-a-service model, corporate partnerships, and training programs. We plan to expand our AI's capabilities by broadening the training datasets to cover more cardiac rhythm variations and patient profiles. For commercialization, we will seek strategic partnerships with medical hardware manufacturers for global rollout, and we will continue to focus on scalability and adoption, ensuring our model is adaptable for a wide range of settings worldwide. In conclusion, our AI-integrated AED system is designed to make emergency care smarter, stronger, and more effective at saving lives. Thank you for your time and attention.
Good morning, everyone. Today, I will be demonstrating how to use an AIAD. Imagine you are in a public place and you see someone collapse. They are unresponsive and not breathing normally. Here are the steps to follow using AIAD. First, check if the area is safe for you, the victim, and others. Do not put yourself in danger. Second, tap the person on the shoulder and shout, "Are you okay? Are you okay?" If there's no response, check breathing for no more than 10 seconds. If the person is not breathing normally, call for help and ask someone to get the AIAD. Turn on the AIAD. Open the pad package and remove the pads. Attach the pads to the bare chest as shown in the diagrams. One pad on the upper right side of the chest below the collarbone, the other pad on the lower left side of the chest below the armpit. Make sure the pads are firmly attached. Now, key in the person data into the AIAD. And press the Analyze button.
Shock advised. Charging. Stand clear. Shock delivered.
After the shock delivered, begin CPR immediately. Follow the voice prompts. Continue until the person shows signs of life, emergency services arrive, or you are physically unable to continue. Thank you.